Hey, Megan. So the second part of your retake test for forces are free body diagram calculations. Okay, there's two of these. Part one, it's going to have you do calculations with one free body diagram. Okay, it's the same free body diagram in each of questions 4 through 6 up there. And then part two, free body diagram calculations, are going to use a different free body diagram. Okay, so there's two different free body diagrams, two sections, but the same free body diagram in each section. See, it's the same thing. Here in question 7 is here in question 8. It's the same thing as in question 9. But these ones are different than the one up in section 2. So, it's the first section for free body diagram calculations, but really the second section because you just did Newton's laws. So I want to show you the review. Okay, so I'm going to give you the helpful hints from the review. So I'm going to go back over here to the review. And on our review, we did the same sort of thing. So use the free body diagram to determine net force and acceleration on the diagrams below. So what I'm going to do is first I'm going to calculate. I'm going to use this one over here on the right. Okay, so I'm going to do this one right here. Okay, so calculate the net force. So the net force, remember, opposite direction subtract, same direction adds. If they're orthogonal directions or perpendicular, you don't add or subtract those. So 7 newtons up cancels with 7 newtons down. Those cancel, those go away. Okay, they net to 0 in that direction, the vertical direction. Now in the horizontal direction, I have 6 newtons plus 6 newtons to the right. Okay, so if we add these ones together, should I write this out? I don't know. No, I'm going to undo that. Okay, so let's just think of these as 6 newtons plus 6 newtons would be 12 newtons to the right. And then we have 2 newtons to the left. So 12 newtons minus 2 newtons would be 10 newtons. 10 newtons. Okay, so I'm going to get rid of all that jazz because that's a lot of jazz. That looks confusing. But I'm going to leave that vertical cancel. So 6 newtons plus 6 newtons is 12 newtons to the right minus 2 newtons to the left is 10 newtons. 10 newtons. And that direction, which direction is it going? Well, the net direction is to the right. So I might even put in 10 newtons to the right. Okay, because we have more force going here to the right than to the left. To calculate the acceleration, what we're going to do is we're going to use this equation right up here. So using the triangle of destiny, which is an algebra tool, acceleration is force divided by mass. Okay, so I'm going to use the text tool here. So force divided by mass, which in this case, the force is 10 newtons. The net force is 10 newtons divided by the mass. And the mass is right here in the middle of the box. So 5 kilograms, 5 kg. So my total, I'm going to delete this other thing here. Should I delete it? Yeah, let's delete it. Okay, let's delete this arrow. I don't like that. Okay, so what that equals is 10 newtons divided by 5 kilograms would be 2. And what are the units? Well, we're dealing with an acceleration, so it's meters per second per second. How did I know that? Well, we have standard units here. We're in newtons, kilograms. The things that go along with that are meters per second per second. Also, a newton is a, see, it's mass. So it's a kilogram meter per second per second. Yes, so kilogram meter per second for the, okay, that doesn't matter. Forget I just told you all that. Acceleration is meters per second per second. Okay, so that's the answer. All right, see you later.